Have you ever wondered how traffic lights know exactly when to change from red to yellow to green and then repeat that sequence over and over again without anyone pressing a button? Well, that's exactly what we're going to build today. By the end of this video, you'll know how to wire a Mitsubishi FX PLC, configure the inputs and outputs, create timer-based ladder logic, and most importantly, make the entire sequence loop automatically. This is one of the most practical PLC programming techniques you will ever learn because the same concept is used in conveyor systems, packaging machines, filling systems, traffic lights, and many other industrial automation projects. So let's get started. Before we even open the PLC software, let's first understand what we are trying to achieve. Our goal is simple. When we press the start button, the red lamp should turn on first. After a preset amount of time, the red lamp should turn off and the yellow lamp should turn on. After another delay, the green lamp should illuminate. Then, instead of stopping, the PLC should automatically return to the beginning and repeat the entire sequence forever. That's what we call a loop sequence, and today you'll learn exactly how to create one. Let's begin with the hardware. I'm using a Mitsubishi FX PLC training kit. The setup consists of a Mitsubishi FX PLC, a 24-volt DC power supply, a push-button module, and a 3-color stack light. Everything you see here is commonly found in industrial automation training systems, making this a great project for beginners. The first thing we need to do is power the PLC. Our power supply accepts 240 volts AC. You'll notice 3 input terminals labeled live, neutral, and earth. These terminals connect directly to the main supply. On the output side of the power supply, we have positive 24 volts and 0 volts, which is also referred to as common. These terminals provide the DC voltage required by the PLC. Now let's wire our input. For this project, we're only going to use one push button. The green push button labeled SB1 will act as our start button. First, connect the PLC's common input terminal to the common terminal of the push button. Then connect the normally open contact of SB1 to input X0 on the PLC. When the push button is pressed, input X0 becomes active. That's all we need to start our sequence. Simple, but very important. Next, let's wire the outputs. Our stack light has 4 wires. One black wire acts as the common connection. The remaining wires control the individual lamps. Connect the red wire to output Y000. Connect the yellow wire to output Y001. And finally, connect the green wire to output Y002. After completing the wiring, press the push button once and verify that input X0 changes state on the PLC. If it does, your hardware wiring is complete. Now we can move on to the software. Open GX Works. Create a new project. Select FX CPU. Choose the correct PLC model. In my case, I'm using the FX3U series. Select ladder logic as the programming language and create a simple project. Once the project opens, configure the communication settings, select the correct COM port connected to your PLC, before downloading any new program, clear the PLC memory while the PLC is in stop mode. Now we're ready to write our ladder logic. Rather than simply copying a finished program, I want you to understand exactly why every rung exists. Because once you understand the logic, you'll be able to build your own PLC sequences without memorizing ladder diagrams. Let's start with the first rung. When the start button X0 is pressed, we energize internal relay M0. Think of M0 as the master switch for the entire program. Instead of using the push button everywhere in the ladder, we only use it once to activate M0. From this point onward, everything else happens automatically. Next, M0 starts timer T0. We are setting timer T0 to 2 seconds. When those 2 seconds expire, timer T0 completes. Its contact closes and energizes output Y000. This turns on the red lamp, so now the sequence has officially begun. Once timer T0 finishes, it immediately starts timer T1. Timer T1 runs for 3 seconds. Here's where something interesting happens. We use the normally closed contact of timer T1 to switch the red lamp off after the delay. Its normally closed contact keeps the yellow lamp energized for the required duration. At exactly the same time, we use its normally open contact to energize the yellow lamp. This creates a smooth transition from red to yellow without any overlap. After timer T1 completes, timer T2 begins. Timer T2 controls the green lamp. When timer T2 finishes, the yellow lamp switches off. At exactly the same moment, its normally open contact energizes output Y002. Now the green lamp turns on. At this point, our traffic light has completed its full sequence. But we are not finished yet, because if we stop here, the sequence only runs once. In real industrial automation, that's almost never what we want. We need the PLC to repeat the cycle automatically. So how do we make that happen? This is where the loop logic comes in. After the green lamp has remained on for 5 seconds, timer T3 completes. That completion starts timer T4. Timer T4 runs for 2 seconds. When timer T4 finishes, it activates the beginning of the sequence again. In other words, the last timer restarts the first timer. And because of that, the entire process repeats automatically. No additional button presses, no operator intervention, just a continuous automatic sequence. This simple concept is used in countless industrial machines around the world. Once you understand timer loops, you are already thinking like an automation engineer. Now it's time to test everything. Download the program into the PLC. Switch the PLC into run mode. Press the green start button. Watch the stack light carefully. The red lamp turns on. After the program delay, the yellow lamp takes over. Then the green lamp illuminates. Finally, the timers reset the sequence, and everything starts again automatically. If your lights are cycling exactly like this, congratulations. You've successfully built your very first automatic PLC loop sequence. Before we finish, let's quickly recap what you've learned today. You learned how to wire a PLC power supply, how to connect digital inputs, how to wire digital outputs, how to configure a Mitsubishi FX PLC in GX Works, how to use internal relays, how to create timer-based sequencing, and finally, how to build a continuous automatic loop that repeats forever. These are the same programming principles used every day in industrial automation systems all over the world. If you are serious about learning PLC programming and industrial automation, make sure you subscribe to Bob Teaches Tech. Here, we don't just explain theory, we learn, build and automate real projects together step by step. Also, don't stop with this video. I have prepared a detailed companion article on bobteachestech.com that includes the complete ladder logic, wiring, diagrams, timer settings, downloadable resources, and additional explanations that couldn't fit into this video. The link is in the description below, and I highly recommend reading it after watching this tutorial. If this video helped you, give it a thumbs up, leave a comment telling me what you'd like to build next, and share it with someone who is learning PLC programming. Thank you so much for watching. Until next time, keep learning, keep building, and keep automating. I'll see you in the next one.